Let's solve this problem. In this problem, there are two identical electrical dipoles AB and CD placed in such a way the angle between them is 120 degree. And since they are identical, they have dipole moment P. Question is, what is the resultant dipole moment of this combination? So first let us try to understand this. If there are two charges minus q and plus q separated by a distance, by some distance, so the dipole moment direction is defined as going from minus q to plus q, minus charge to plus charge. So this is the direction of the dipole moment vector. Now let's draw the dipole moment vector for these two dipoles. So this is the y-axis and this is the x-axis. This is the x, this is minus x, this is y, and this one is minus y. Since AB dipole is along the y direction, the dipole moment vector goes from minus q to plus q. So it should be like this. This is the dipole moment vector of AB dipole. Now, CD dipole making an angle 120 degree with AB, and then we can draw the dipole moment of CD dipole like this. This angle is 120 degree, and let's call this as P vector CD of the CD dipole. Now let's write the vectors of these dipole moment. So P vector of AB dipole equals modulus of PAB and it is along the positive y direction, so it is along j cap. I can write this as PAB j cap. Now let us write P vector CD in a similar way. For that, we should know the components of PCD vector. So let's take this as some angle theta and draw a perpendicular line here so that the sine theta component will be here. This is PCD sine theta, and this is the cos theta component. This is PCD cos theta. So we can write PCD cos theta acts along positive x direction and PCD sine theta acts along the negative y direction. So we have to write minus j cap. Now to find out the resultant of these two vectors, we have to add them. Adding the x components and y components separately will get the resultant dipole moment vector. Let's call that as P vector, PR vector, which is equal to PAB vector plus PCD vector. We have only one I component, so it will be PCD cos theta I cap minus PAB, no, maybe plus minus PCD sine theta, and we can keep it in a bracket here, j cap. Now to find out the magnitude of this resultant vector, we have to square the components, x and y components, and take the square root. So square root of x component square plus y component square. Everything under the square root. Uh, let's expand this. PCD squared cos squared theta, and let's expand the second term as a minus b whole squared form. Using that identity, we can write PAB squared plus PCD squared sine squared theta minus 2PAB PCD sine theta. Extend the square root. Now, if you write here, taking these two common, so we can write this as PCD squared cos squared theta plus sine squared theta will become 1. So we'll have PAB squared minus 2PAB PCD sine theta. Now at this moment, we can see here, um, since these two dipoles are identical, we can write P vector AB actually equals to P, no, their magnitudes are the same. So we can write PAB equals PCD, which is equal to P. Now this will become the magnitude of the resultant dipole moment will become square root of P squared plus P squared minus 2P squared sine theta. So to find this theta, let's go back and see this diagram, vector diagram again. And if you observe here, the angle, the total angle between the two dipole is 120 degree, and that can be written as 90 plus theta, which is equal to 120 degree. So theta equals 120 minus 90, that will give you 30 degree. So this we have found out it is 30 degree. Now let's write that here, and we can write this like p squared 2p squared minus 2p squared sine 30 degree. Sine 30 is actually 1 by 2. So 2 will go away. You will have 2p squared minus p squared will be square root of p squared, and that will be equal to p. That's it. So we have found out the resultant of a dipole moment, that is actually p. Now to find out the direction of the resultant dipole moment vector, we are going to use tan theta, and let us just call this as tan theta prime because it is the angle of the resultant dipole moment vector. For example, if we draw the resultant dipole moment vector somewhere like this is PR. And what is the angle it makes with the horizontal? That's what we are going to find out. That is, let us call that as theta prime. So now tan theta equals the y component of the resultant vector, that is this one divided by this will give you the direction of resultant dipole moment vector. So let us write that here. Y component of this is y component is PAB minus PCD sine theta divided by x component is PCD cos theta. Now let us just use everything is the same. So we know P minus P sine theta divided by P cos theta. So all the P's will go away. We can write this as 1 minus sine, here it is 30 degree divided by cos 30 degree. So You can write this as tan theta prime equals 1 minus 1 by 2 divided by root 3 by 2, which will be 1 by 2 times 2 divided by root 3, which gives you 1 by root 3. So theta prime equals tan inverse of 1 by root 3, and that gives you 30 degree. So this is the direction of resultant dipole moment vector. Now the part B question in this problem is if the system is subjected to the electric field E directed along the x direction, so along the x direction there is an electric field, what will be the magnitude and direction of the torque acting on this? So we have to find out the torque. So for torque, we are going to use tau is equal to R cross P formula. So we know tau equals P cross E, I'm sorry. So it's a PE sine theta is equal to PE sine, once again, 30 degree. That is, this 30 degree is the direction of resultant dipole moment vector that makes with the horizontal. So PA, so it will give you 1 by 2 PE. So that's the torque here. And the direction can be found out by the right hand thumb rule. So it is into the plane, which means along maybe minus z direction. That's all. We solved this. Thank you.